Welcome to the Using Autodesk's Tinkercad software to create virtual circuits tutorial. Now, you've probably used Tinkercad to create virtual 3D models that can be turned into real objects using a 3D printer. Today we'll be using Tinkercad to create virtual electronic circuits. There are many benefits to creating a circuit virtually before creating a real one. It's a lot faster than making a physical circuit. It allows you to work on your circuits anywhere you have a computer and not only in the places where you have all of your electronic components. It lets you use components that you don't own, and it automatically creates schematic views and component lists to save you a lot of work and time in the future. So step one is to open Tinkercad and log into your account using your school login details. Once you're there, you'll be in this welcome page here. On the left in the center, under your designs, you'll see a box that says Create. If you click that, you can move down and select Circuit. You can now create a circuit in the Tinkercad circuit building area. The first thing you want to do though is go up to the top left hand corner and change the name to your name. Mr. V Circuit. Click anywhere else and that should save it. This makes it easy for me to come back and find my circuit in the future. Now, before we make a simple circuit, we need to know that a circuit is made up of lots of small components. Each little part that we're going to use to make our circuit are here on the right hand side. You can scroll up and down and find different ones. We'll start by choosing the breadboard, click and drag and release. And now the breadboard is on my building area. If I want, I can name the breadboard. It's not really that important when I'm doing very simple circuits, but if I'm doing circuits with lots and lots of parts, I might want to know which one is button 2, button 3, button 4. So that's a really good place you can label different parts. Now a breadboard works like this. It's a lump of plastic with lots of little holes in it. And within the breadboard, these holes are connected to each other using thin strips of metal. If I hover over one of these little dots, which represents a hole, other ones glow green. Those are the other holes connected in the circuit. Let's go down and see which other ones are connected. So all the negatives and all the positives are connected to each other. These are places where I can connect a power supply. And if I go down to the bottom, you'll see I've got the same feature there. In the center, where all the holes are numbered and lettered, the holes are connected in a different direction, and this is where I build my circuit. Let's start by adding some power to the breadboard. We'll choose a 9-volt battery, click and drag. If I line up the terminals of the battery to the holes on the breadboard, it will snap into place. The battery is now providing power to these two lines of dots, and I can draw that power to run my components. Let's come over and get an LED. An LED stands for light emitting diode. I'm going to drop it just up here in the very top where it says J1 and J2. A diode is a one-way gate for electricity. It will only let power through one way. The cathode, which is the straight leg, connects to the negative power. The anode, which is the bent leg, connects to the positive power. If I put this in backwards, the electricity won't flow through and nothing will happen. If I put it in the right way, when electricity flows through, I'll know because it emits light. Now, before I connect this LED to the power, it's really important to know that the 9-volt battery here is providing too much power for this little LED. If I were to connect it up, the LED would have too much power, it would get overloaded and it would blow. It might glow very brightly for a very short point of time, but then it would break. So I need to put something into the circuit which will reduce the amount of electricity flowing through the LED. And that tool is called a resistor. I drag my resistor in line with the anode, in line with the cathode, and I drop it so that it bridges over the gap, that grey line, in the middle of my breadboard. This means that any power coming up through here has to travel through the resistor to get to the LED. These ones are connected, we can see that. So now we need to connect the resistor to the negative power. I do that by clicking any of these buttons, dragging the mouse down, and that drags a wire. And then I click again on the hole I want to draw it to. Now let's jump back to the resistor. It's connected now, but I need to make sure it's the right type of resistor. Different resistors will limit the power running through them differently. To edit the resistor, I click on it. I come up to the information panel here, and I'm going to change the name. I'm going to change the resistance to 470 ohms. I can choose here. Let's have a look. We've got pico ohms, nano ohms, micro ohms, milli ohms, ohms, kilo ohms, mega ohms, and giga ohms. We're going to choose ohms. And that's changed the color coding of the resistor, which tells me that is a 470 ohm resistor. All I need to do now is to connect the anode to the positive part of the to the positive power, and we're ready to go. Let's do that. Click, click, and we're finished. If I'd like to see this working, I come up to the Start Simulation button in the right-hand side and click it. When I click this, if everything's done correctly, the LED should light up. Let's have a look. And there we go. If for some reason yours isn't lighting up, just check to make sure that you have the resistor set correctly, 470 ohms. Check that your cathode is running through the resistor to the negative power supply, and that your anode is running through to the positive. If you've done all that and it's still not working, check that your battery is connected with the positive and the negative. And if it's still not working, get a buddy to check your work. It's very easy to miss things when you're doing circuits. Let's stop the simulation and modify this circuit. I'll get rid of this green wire here. If I hover over it, it glows blue. I click it, I can see it selected because the ends are highlighted, and I can delete it by using the trash can button. And away it goes. I'm now going to add a button so that I can turn the LED on and off at will. I'll use a push button. I'll drag it over here. I'll line up the left-hand terminals with the anode. These are terminals 1A and 1B. When I press down this button, the terminal 1s connect to the terminal 2s on the right-hand side. I'll connect the right-hand terminal down to the positive. I will click Start Simulation, and nothing's happened. But when I hover over the button and click it, let's see what happens. The light comes on. Release the click of the mouse and the light goes off. So I'm now completing the circuit and breaking the circuit. Completing and breaking. So now we've made our circuit. There's a couple of great things you can do in Tinkercad that you can't do by using a real circuit. The first thing is, if you go up to the right-hand side here, you can click this button that says Schematic View. When you do that, it gives you this view. This is what your circuit looks like when you draw it technically. Up here in your circuit view is what it looks like in real life. But if you want to share this with an engineer or a factory to build your circuit, this is what you have to send them. You can easily download this as a PDF. Let's say you want to send this to someone to go to the shops and buy all the parts so you can make this circuit for real. If you click up here on the right-hand side component list, it now gives you a shopping list with the names that you've given your components, how much of each one you need, and what the component's actually called. You can download this as a CSV, which is comma separated values, which can be opened up in lots of different bits of software, including Microsoft Excel. So let's go back to our circuit view. I'd now like you guys to do a bit of experimentation. See what happens when you change the resistance of the resistor. What happens to the LED when you give it more or less resistance? I'd like to see if you can make a circuit where more than one LED turns on when you press the button. And if you manage that, see if you can make a circuit where different buttons make the LED glow at different strengths. Good luck.